Hello friends, welcome to this machine design online classes. Okay. So we'll go for first the syllabus. So it consists of 4 units. As you know, first unit is related to introduction. So in that you're going to cover the definitions like normal, shear, biaxial, triaxial stresses and a stress tensor. Next is principal stresses. Next, engineering materials and their mechanical properties. Stress strain diagrams, stress analysis, design considerations, codes and standards. In second chapter, you need to design for static strength and for impact strength if a component is subjected to the static load as well as the impact load. Now design for static and impact strength. So what do you mean by static strength? What is the static load and factor of safety? So next, theories of failure, maximum normal stress theory, maximum shear stress theory, distortion energy theory. Okay. Failure of brittle materials and failure of ductile materials. Now, what is the meaning of stress concentration? How to determine the stress concentration? And what are the factors associated with in the reduction of stress concentration? Impact strength. What is the intended impact strength? Impact stress is due to axial, bending, torsional loads and effect of inertia. Unit 2, it has two chapters. One is design for fatigue strength. It includes introduction, what is a SN diagram, what is low cycle fatigue, high cycle fatigue, what do you mean by entrance limit and entrance limit, and factors which are going to affect the entrance limit. Okay, that is what size effects, surface effects, stress concentration effects, as well as need to study the fluctuating stresses. Okay. So we have two relations to find out the entrance strength or to find out the dimensions when a component is subjected to fluctuating stresses for ductile material as well as for brittle material. Okay, so those two equations are a Goodman relationship and a Soderberg relationship. So next, stress due to combined loading, so cumulative fatigue damage. Next, the chapter is threaded fasteners. Now, what are the stresses we are going to occur in threaded fasteners? Then, what is the effect of initial load? Finally, we go on for tightening the bolt or tightening the fastener. Okay? Then, design of threaded fasteners under static load, dynamic load, and impact loads. Next, design of eccentrically loaded bolted joints. Okay? Next, unit 3. So, it is a design of shafts, so which is to be based on the strength and rigidity with steady loading. Next, ASME and BIS codes for power transmission shafting and shafts under fluctuating loads and combined loads. In unit 3, you have one more chapter, that is what quarter joint and knuckle joints, keys and couplings. Now, design of quarter joint, design of knuckle joints, next design of keys, what are 5 keys, and next you have two couplings here. One is a flange coupling, another one is a design of Oldham's coupling. Okay? So rigid and flange flexible couplings. In that you have flange coupling, bush and pin type coupling, and Oldham's coupling. Chapter 4 is related to the riveted and welded joints along with the power screws here. In riveted joints, what are the types of rivets? What are the rivet materials? How the failure of riveted joint will occur? Then what is the efficiency and what are the boiler joints? So boiler joints related to a tank as well as structural joints, riveted brackets. Next, in welded joints, you're going to get a types. What are the different type of welded joints? Then strength of butt and fillet welds, eccentrically loaded welded joints. Next, design of power screws and that mechanics of power screw, stresses in power screws, efficiency and self-locking, and design of power screws. And last bit is the design of screw jack. That is what complete design. That is of bottleneck. Okay? Now this is what brief syllabus of machine design 1.